Hello and welcome to the third video of this tutorial series on how to integrate the SCILL API in your Unreal Engine game. Here we want to have a look at how to actually implement the SCILL Unreal SDK in your game client. To recap the last video, we have had a look at the different features of the SCILL API that help us create user retention. After that we moved on to the Unreal SDK of SCILL and had a look at its general structure and already discussed some important notes on how to implement it in your game. We decided to go for a client-server structure of your Unreal game to cover all features of the SDK, although it would be fine to just create the game client and move the server's logic to a secured HTTP API. So now let's open the Unreal project. To start, we will need to add the components and interfaces to your projects like discussed in the last video. To keep the project a little bit cleaner, we will just inherit from the existing blueprints and then add the corresponding components in the inherited classes. Go to the Blueprints folder and add a new folder for our skill-specific blueprints. I call it Skill Sample, but you can call it whatever you like. In here you can right-click and hit Blueprint Class. In the upcoming dialog, expand the All Classes tree view and search for the BP Player Controller class and select it. Give the new blueprint a name like BP Skill Player Controller and repeat these steps for the BP Game Mode and BP Game Instance classes. In order to pass an access token to the client like discussed in the previous chapter, we will first need to create the according method on the backend component. Since an access token is required to access the SCILL API at all from the client, we will do that first. So now we open the newly created SCILL Game Mode blueprint and add the SCILL Client backend component here. For testing, you might also already copy and paste the API key of your app to the API key property of this component. But as already mentioned, during your production, you would rather like this at a protected location only accessible to the game server and loaded during runtime. But first, the property is just okay to use. Now we create a function that takes a string, the user ID, and calls the generate access token method on the SCILL Client backend, like this. In order to properly handle the response, we need to also pass a reference to a function that handles the incoming response from the SCILL API. The backend component is used only to provide the API key and does not need to do anything with the response, so we can let the game client handle the response. Drag and drop the delegate input from the generate access token function on the input node to create a matching delegate input here. That's it for now, and we can finally switch over to the SCILL Player Controller. Now to understand the SCILL Player Controller a little better, you need to remember that both the game server and the owning game client have an instance of that class. This is in contrast to the game mode, which only exists on the server and not on any of the connected clients. Owning client also means that the player controller only exists on that game client that is owning this specific player controller. All player controllers of any other player character only exist on the respective clients. Okay. That is that. Now let us start to generate access tokens. Add a SCILL Client component to the SCILL Player Controller. Again, for testing purposes, you can add a user ID and your app ID to the properties of the component. Contrary to the API key, the app ID is safe to share, since it alone will not enable anyone to make changes to your application in any way, and can be left as a default value for the component's property. Next, add an event to your event graph. It will be called Server Generate Access Token. We use the server prefix to indicate that this event will be executed on the server instance of our player controller. To really do that as well, you will need to adjust the replicates property on this event and set it to run on server. This will call the event on the server instance if it was called on the owning client. If the event is called on the server, it just runs like any non-replicated event. Make the call reliable, since we really need the access token on the client side. Normally only cosmetic replications are set to non-reliable. Reliable means that the engine will check whether or not the event has reached the server and retries the replication if the call got lost somewhere. This takes up performance and should not be done on calls that are made repeatedly, and only if the events are crucial to gameplay. The event is executed on the server, and so now we have access to the game mode. We can now create the logic to generate an access token by calling the corresponding function on the game mode. To maintain some structure, we will capsule that in a function. Here we get the game mode, try to cast it to the skill game mode, and if that succeeds, we call the generate access token function here. Now drag off the delegate of that function, drop anywhere in the graph and select create event so that we can connect it to a function. In the dropdown you can either select an existing function or event, or we just create a matching one. Conveniently, the editor directly jumps into the created function and we can handle the response of the API call here. The SDK simply returns the token as a string here and a boolean indicating whether the request was processed successfully. So we check against that boolean, and if it is set, we need to set the access token property on our skill client. But remember that we are still on our server instance of the player controller at that point. So we need to first pass to an event on the owning client. In the event graph, again create a new event that takes a string. Call that input access token and set the replication enumeration to run on owning client. Also tick the reliable flag here again. To stay in the naming convention, call the event something like client set access token. Client indicates that it is running on the owning client if it was called on the server. In this event we set the access token on the skill client. If needed, you can also call the retrieve user info or set to default after that to make sure that the user has a default name and image set for their appearance on the leaderboards. Now that we have all necessary functions up, we just need to call them. So return to the begin play event, add the server get access token event, go to the callback function of the generate access token call and add the client set access token event here, and we are done for now. Now, this is all fine as long as we do not switch the level at any time and our player controller consequently gets destroyed. To get rid of that problem, we will implement the level persistence interface on our custom game instance now. Open the blueprint. Here you want to add two string instance variables, user ID and access token. Then go to the interfaces and double-click or right-click each of the methods to create a corresponding event or function. Set or get the corresponding instance variable and you're done. What the SDK does in the background is the following. The skill client component on startup searches for the game instance and tries to cast it to the level persistence interface. If successful, it tries to read the user ID and access token to set it on its own instance variables. If there are none, nothing is set and the defaults are used instead. Also, if you use the set access token or set user ID accessors on the skill client, the client tries to set these on the game instance in the same way. So after implementing these interfaces, you do not need to care about this logic anymore. Let us try to send requests to receive information and take actions. You can simply drag off the skill client component after placing it in the blueprint graph. Then select the function you want to call. Again, you will have to work with callbacks. This way you can do anything that you need. In this tutorial we do not need to call any other functions for now. Most of this is done in the UI preset that we want to implement now. You can either use the classes directly or inherit your own widget blueprints from those classes, or just copy and paste the blueprints to your game's content folders to modify their appearance to your liking. For this tutorial we will leave them as they are. Create input actions in your project properties that we will use to open the respective menus. For example, we can use the B key for the Battle Pass canvas, C for challenges and L for leaderboards. Once done, you can add an event to your player controller for each input action. We will just create a logic to open and close the corresponding widget. We use an enumeration to indicate the currently open menu. Right-click in your skill sample folder and create an enumeration and call it skill menu. Call its fields none, battle pass, challenges and leaderboards. Now create an instance variable of that type on the player controller and we call it current menu. We also add a SCILL menu reference instance variable of type user widget. Add a function to the player controller and call it something like menu button pressed. Pass a SCILL menu enumeration as input. In this function we check against the current menu, and if they are the same, we just remove the SCILL menu reference object by removing it from parent and then setting the SCILL menu to null. After that we change the current menu enumeration to none. Next we switch over the enumeration. For each case create a user widget of the corresponding preset from our SDK. Then set the SCILL menu reference to the newly created widget and set the enumeration accordingly. We can also add an action for closing all menus. For this we create another path for the none case and use that for this input action. This is all you have to do to integrate the UI presets in your game, and as you can see, everything that you need to program yourself has to do with how you want to handle the UI in your specific game. Now we can test everything and see if it all works in conjunction with everything else. That already wraps up our video about what to do on your client. We now have proper feedback for your user on available challenges, battle passes and more. You can now adjust the code to what is required for your specific game. Also feel free to dive into the finished project and have a look at some aspects of the implementation that you might not have completely understood yet. If you struggle to follow at some points in the tutorial, you might also want to have a deeper look at the respective concepts of the Unreal Engine itself in the Epic Games documentation. In the next video we will discuss how to handle everything on the server side of your Unreal game. We will mainly talk about detecting specific player actions, sending events and retrieving updates to pass rewards to the players when needed. So see you in our next video, take care and bye.